when we are working with logarithms. If you have two exponentials that are set to be equal to each other and the exponents optically look different, they can only be equal to each other if the exponents are equivalent. So here's a real world example of this. If I have 4 to the 2x equals 4 to the 20, I have two exponentials that are equal to each other with the same base. Rather than going through logarithms and blah, 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 I can say, hey, if these two are equal and they have the same base, then I can say, okay, 2x must be 20, and therefore x equals 10. Okay, so as much as possible, we want to get our equations to look something like this. This is also true with logarithms. If you have two logarithms with the same base and they are set to be equal each other, but the insides of the logarithms look different, by definition, if the left side equals the right side, then the insides must also be the same. So for example, it could look like this. If I have log base 4 of 2x and it is equal to log base 4 of 20, I have two logarithms with the same base. The equation tells me they are equal to each other. Therefore, the insides must be equal to each other. And I can just ignore the stuff on the outside because everything on the outside is the same on both sides. Okay, so we're going to use these to our advantage today. The other thing that we need to remember is at some point we're going to get quadratic equations, right? And when we have quadratic equations, usually we end up with two solutions. And so there is a possibility that we are going to get extraneous roots, means extra answers that don't actually fit our equation. This is how we're going to check. We are going to look at the equation, and we have to remember that for a logarithm to work, the inside of the log must be a positive number. So whatever's on the inside must always be positive. And the base of the log must be a positive number, and it cannot be 1, because remember, when we have an exponential with a base of 1, we actually just have a flat line. It's not an exponential. So we can't have it be equal to 1, and we can't have it be a negative number. And if you don't remember where these rules come from, go back in your notes. Go back to where we first introduced logarithms and the definitions and the domain and all that stuff. We talked about it in a previous lesson. Okay, putting all these together, we are going to solve. Solve means now I'm looking for x equals something as my final answer, rather than just simplifying. So in the past, we looked at example 1 and said, hey, you know what? I can rewrite 8 as 2 to the 3. And I have 2 to the x equals 2 to the 3, and therefore x must be 3. This is how we used to do it, which is still a valid form for a simple question like this. But I want us to get used to how to work with logarithms because it will get complex later on. When we are solving using logarithms, we are changing the original equation from exponential form to logarithmic form. So I'm going to rewrite this as x equals log base 2 of 8. Right? The base of the exponential becomes the base of the log switches sides on the equal sign. And then I can use my logarithmic rules and say, hey, I know that I can rewrite 8 as 2 to the 3. And the exponent becomes the coefficient. And one of our rules is if the base and the inside are the same, this just simplifies to 1. And I'm left with x equals 3, which I know already is the answer. So I know this is correct. There's another way I could do this. What if it wasn't 8 and 2? What if these were really ugly numbers? I'm going to do example 3 because example 3, you can see that 3 and 11 are both primes. They have nothing in common. There's no way that I can rewrite this. So the way that I would solve something like this is to say, okay, this is going to be, sorry, I'm going to do the log, rewrite this as a logarithm. This is log base 3 of 11. I cannot rewrite this in a way that cancels out, right? I cannot write 11 as a base 3 exponent. So what I'm going to do is I'm going to use one of my rules because I want to use my calculator to figure this out. I can do a change of base. My calculator only understands base what? Base 10. So I'm going to change this into base 10. When you do a change of base, the original base becomes the denominator and the interior becomes the numerator. So this is log 11 over log 3. When we have a log base 10, we don't need to write the 10 part. The 10 is always assumed. So this becomes a calculator question. I want you to grab your calculators and type in log 11 close bracket divide by log 3 close bracket. What'd you get? 2.18 or 2.2 or something. It's going to be a decimal. It's not an exact number, but that's a calculator question. That's okay. All right. So sometimes it works out that we don't have to do a change of base. We can just manipulate the numbers that we have and simplify. And sometimes we just don't get nice numbers and we have to use our calculators. Okay, let's take a look at example 2. Example 2, there's a log of something plus a log of something equals a number 1. Before I go to solve this, I want to simplify as much as possible. What rule can I use here? I see that there's a plus sign between the logs. I notice that both logs are base 10, so they are the same base. I can have the insides multiply, right? So I can use the sum rule. This is log x times x plus 3 equals 1. Now I want to solve for x. X is inside the logarithm. How do I get rid of a logarithm? What is the inverse of a logarithm? What's the opposite? Exponential. If I want to make this an exponential equation, what would be the base of my exponent? How do you know it's 10? The base is log 10, right? Whenever we don't see the base, we know that there's a 10 in there. So I'm going to rewrite this as an exponential. This is x plus 3 equals base 10 to the power 1. Well, now this is just algebra. I can do this. This is x squared plus 3x minus 10 equals 0. Now it's a quadratic. Everything to the same side. I expanded the bracket. I can use magic numbers. What would work here? Negative multiplies to negative 10, adds to positive 3. Plus 5, negative 2. So my options here, my solutions are x could be negative 5 or x could be positive 2. But I am not done. This is not my answer. I started my equation with logarithms. Logarithms have restrictions. I have 2 restrictions here because I have 2 restrictions. I have 2 logs. Inside of the log, I must have a positive number. That means x plus 3 must be greater than 0 and x must be greater than 0. Remember how we do domain of logarithms. The domain of the logarithm is where these 2 overlap. What's the overlap? Greater than 0, right? So my restriction is that x has to be greater than 0. So right away I can say, oh, can't do -5. It does not fit my restriction. So my final answer is that the only possibility here is that x can be 2. All right, example 3. In example 3, I have 3 logarithms. 1, 2, 3. That means I have 3 restrictions. We can even start with the restrictions this time. Restrictions. X plus 6 must be greater than 0. So that means x must be greater than -6. X plus 2 must be greater than 0. Therefore, x must be greater than -2. And then x has to be greater than 0. The only overlap is this one. So I'm looking for positive solutions in this case. Okay. Notice that both sides have log base 3. So let's simplify the left side. What rule can I use here? The quotient rule, right? This is going to be x plus 6 over x plus 2 equals log, oh, my pen is not liking me today, log base 3 of x. Okay, look at rule number 2 at the very top of our page. I have 2 logs with the same base, but different stuff on the inside. If these are equal, that means the inside is equal. So I only have to worry about the inside. So this means that x plus 2 must be the same as just x because of the rule that we just talked about. And again, this becomes just an algebra question. I can multiply both sides by x plus 2 to get rid of the denominator. I'm left with x plus 6 equals x squared plus 2x. Notice that I'm building a quadratic here, x squared plus x minus 6. What are my possibilities? +3, -2. Therefore, my x solutions are -3, +2. However, check my restrictions. What am I rejecting? I reject the -3. So my final answer to this equation is x can only be 2. Questions, comments, concerns? So what I'm trying to do here with logarithms is pattern match. Simplify first, match left side and right side if possible. If not possible, then maybe we need to change form. Maybe we have to go to exponential, or maybe we go to logarithm. When we have our answer, we check, is there a restriction that we need to verify? Okay, so let's do the next one. Restriction. This one, x has to be greater than 1. This one has to be greater than 0. This has to be greater than 0. Where's the overlap? Overlap is our solution has to be greater than 1 in this case. Okay. Notice that we have log base 3, log base 3, log base 3, and a constant. I can't combine a constant with a logarithm. So what I'm going to do, because they're all base 3, I'm going to put all the logs on one side, all the numbers on the other side. I'm also going to rewrite my coefficients back as exponents just to make things a little bit simpler. This is going to be log base 3x squared plus log base 3 x minus 1 minus log base 3 2x equals 1. All of these have the same base 3. There is a plus here and a minus here. So I can actually combine all of this into one thing. This is going to be log base 3 of. The two things that are plussing now are multiplying together. So this is x squared times x minus 1. And the thing that we are minusing becomes a divide. So this is over 2x equals 1. Okay, I have simplified as much as I can. What's my next move? I'm looking for x. Amber. Almost. Say that again. The stuff inside the bracket equals 3. How did you do that? Yeah, we rewrite it as an exponential first to get those brackets free from the log, and then we'll do what Amber suggested, right? So this is going to be x. Oopsie, I'll change my pen here. Make it an exponential first. This is x squared x minus 1 over 2x equals 3 to the 1. And then we go through and do BEDMAS. Can I show you a quick simplification though? X on the bottom, 2 x's on the top. I can reduce by 1, right? This x will get canceled. So there's 1 x on the top, and then I just have a 2 on the bottom. So then I have x times x minus 1 equals 2 times 3 is 6. X squared minus x. I'm going to bring everything to the same side. Again, I end up with a quadratic, which is nice. We like quadratics. We know how to do those. What are my two possibilities here? X negative 3, x plus 2. So my options for solutions are 3 and negative 2. Look back at my restriction. What am I canceling out? I reject the negative 2. Positive 3 is my solution. Questions, comments, concerns? Okay, so all of these are going to get progressively more challenging, but I want you to follow the pattern. Simplify and collect terms as much as you can. If you have a logarithm, make it an exponential. You have an exponential, make it a logarithm. You want to get rid of those until you end up with either an x equals something linear or a quadratic. Okay. The next page, more challenging. I am starting with an exponential. It happens to be that my exponential has a log in it, but I'm starting with an exponential that has a restriction. My restriction here is that x has to be a positive number. Okay. I don't like this. I don't want any exponents. I'm trying to simplify as much as I can. So I'm going to change this to a logarithm by doing a base x log of the other side. So this will be log base x of 100x. And on the other side, I'm left with log x. Okay. Next thing I want to do is I want to check the bases of these. Notice that these are different bases. This is a base 10 logarithm. This is a base x logarithm. They are not the same. So either we change the right side or we change the left side. We want this to be the same bases so that we can combine them, right? I'm going to choose to work with log base 10. So I'm going to change the right side. So this is going to be log of x equals log of 100x over log of x. So I changed it. Now all of my logarithms have a base 10. And now I can start manipulating it a little bit. I'm going to multiply both sides by log x to get rid of the denominator. This will give me log of x all squared. Not log of just the x squared, but the whole thing is squared because I multiplied it by itself. And on the other side, I'm left with the numerator, which is log 100x. So it's starting to get simpler, but not quite yet. I'm going to use the product rule to split this into two things. This is going to give me log of x all squared equals log 100 plus log of x. Zoom in on this one. What is this base? This is a base 10. Can we write 100 as a base 10? Okay, this is 10 to the 2, and we can always write the exponents as coefficients. So this is actually 2 log 10, 10. Log 10, 10 simplifies to 1. So then I can actually just reduce that entire piece to just the number 2, right? Let's do that. Log of x all squared equals 2 plus log x. Ooh, I kind of have a quadratic. Let's move this all over to the same side. Log of x squared minus log of x minus 2 equals 0. Okay, in our brains, let's rewrite it like this. A squared minus a minus 2 equals 0. The entire log is a quadratic here. What would be my options for factors? -2, +1. So log x minus 2 log x plus 1 equals 0, right? We're just doing a little substitution here because I can see that this is a quadratic. Just called that piece A. Okay, so then this leads me to believe that log base 10 of x is 2. How would I write this as an exponential? Yes, say it louder. Yeah, x equals 10 to the power 2, right? Because this is log base 10. We chose it to be base 10. So that means x is 100. The other option is that log of x equals -1, which means x is how would I write that? 1 over 10, right? And you can leave it as a fraction or you can write it as a decimal. Doesn't really matter. It doesn't say either way. Now, let's check back with our restriction. Our restriction was that x must be positive. Well, looking at our answers, they're both positive. So they both work. I get to keep both. Okay, so what we're doing here, substitution, pattern matching, trying to manipulate it to get into quadratic form so that we can solve it. It looks very scary, but once you kind of start doing it, you'll see the patterns come out very, very quickly. Okay, let's do number 6. Here, I have exponentials on both sides. There are, because these rules are kind of flexible, there's many ways to approach this problem. I believe the easiest way is to take the log of both sides, but there are other ways that you could start this problem that would work just as well. So I want you to think of the time in Unit 2 where we solved radical equations. Do you remember when we had something like this, where we had x minus 2 equals like 8x? And the way that we solved this kind of question was to square both sides. And then we got x minus 2 equals 64x squared. Do you remember how we did that in Unit 2? Okay, we're going to do the same thing, but now instead of squaring everything, we're going to log everything. Okay, when we have exponentials on both sides, we are just going to put everything in brackets, and we're going to log both sides. So this will be log of 3 times 2 to the x minus 2 equals log of 6 to the x. And now we're going to expand it using log rules. I see a multiplication in the first one, so this is log 3 plus log 2 to the x minus 2. X log 6, right? Because I can take an exponent and make it a coefficient. I'm going to do the same thing with this exponent as well. Log 3 plus x minus 2 log 2 equals x log 6. I'm going to distribute this coefficient. Log 3 plus x log 2 minus 2 log 2 equals x log 6. You'll notice now that each of the logs only have one thing inside, and that all of them are numbers, which means I can simplify them very quickly because I can just throw these numbers into a calculator, right? My goal here is to get x by itself. So I'm going to move the logs that have an x to the left, and anything that doesn't have an x, I'm going to move to the right. So this will be x log 2 minus x log 6 equals 2 log 2 minus log 3. And now I can factor that x out. X log 2 minus log 6 equals 2 log 2 minus log 3. Okay, and to get the x by itself, I'm going to take this and divide it to the other side. You see how I did that? Just going to move it over here just to save me a line of writing. Okay, so I'm just going to divide it, and all of these are base 10 with numbers in it. You can just chuck this into your calculator. Just make sure you have brackets on the top and brackets on the bottom. If you want to do a little bit less typing, you could condense it a little bit more. This is log 2 squared over 3 over log 2 over 6. You could condense it if you wanted a little bit more, just to save yourself some typing on a calculator. You don't have to, though. But this is something we just put into our calculator. Can you do that? Tell me what you get for x. You can put either version in. You should get the same answer no matter what. Just make sure you're using your brackets carefully. I'll give you a head start. It's a negative number, and I think it starts with a 0. 0.26. Okay, approximately. Yeah. Do I have to check restrictions here? Does my original equation have logs in it? No, so I don't have to worry about restrictions. We only worry about restrictions when the original equation has logs. If the original does not have logs, we don't have to worry about it. Questions, comments, concerns? All right, let's do the last two. Solve for A in terms of B and C. So now we're just practicing our rearranging rules. Here's my equation. Here's the bit I want. What could I do? Can I simplify anything first? Are the logs the same base? Can I put them together as one? If not, can I rewrite it? Can I move something? What can I do here? I can do the quotient rule and combine this, right? This is log of A squared over B, right? Because the 2 in front of the A is its exponent, so it's got to carry it with it. So log A squared over B equals C. I want just A by itself. What's my next move? How do I undo the log? How do I get rid of it? Exponential, what's the base of it? A 10, right? Because I didn't write it here. When it's not written, we always assume this is a 10. So this is A squared over B equals 10 to the power C. What's my next move? A squared equals B times 10 to the C. Last move. A is the square root of B times 10 to the C. I'm going to add plus minus, because when we square root, we'll always get 2 answers. Okay, so we are manipulating the laws to rearrange for what we want. Always start with, can I simplify? Okay, example 8. If the log of 3 is A and the log of 8 is B, determine what is the log of 18 in terms of A and B. How could I write log 18 in terms of A and B? What's the base of all of these? This is a base 10. Let's see if I write it like that, if that's helpful. If I write this as a 10, and I have log of 8 is B, which is a base 10, how could I write log of 18 using these two numbers? Okay, here's another way of thinking it. Let's call this C. I want to know how to get C from A and B. Adding, subtracting, dividing, combining. What can we do? Take a look at your rules. Let's get creative. Can we write log 18 as a product of two numbers? Okay, what makes 18? Three squared times 2, which is the same as log 3 squared plus log 2. Now we can change it. We don't need to change base necessarily. They're all base 10. 2 log 3s plus 1 log 2 this matches this. So that could be, what is this? 2a plus can we rewrite this? How? This is 3 log 2 equals b. I only want 1 log 2. How do I do that? If 3 log 2s make a b, and I only want 1 of them, what do I do to the b? Divide by 3. There. Okay, Delta Math Unit 5 has every lesson practice homework that you need. I want you, before the test comes on Tuesday, to have every assignment done, minimum 3 green check marks in a row. Okay? Your homework is attached, or you can do Delta Math. Either way, it's up to you, but we are done for today.